Hello guys, today we are going to start the new video of Numpy series. So in this video we are going to discussing about the Numpy versus Python list. Okay, so why Numpy is very faster than Python? Okay, what are the reasons are there? So we are going to see one by one. Okay, so just before that, starting initially. Okay, so here we're going to understand what is the Python. Okay, so Python list. Okay, a Python list is a collection that is stored and changeable. Okay, so it is a collection of data, or we can say variable, and it can be changed or it can be ordered. Okay, so list basically the list are written in the square bracket. So it is basically very basic information I just given, because my intention is not focus on Python list. Okay, so I'm just giving some information about the Python list. Okay, so what are the some points of Python list? Okay, so Python list can be homogeneous or heterogeneous. Okay, so I can we can say what is means by homogeneous and heterogeneous. So for that we're going to go to here collab. So most of the people knows it is a collab platform provided by Google. So here we can do our programming regarding Python, NumPy, pandas, all this, and it is freely available and it's very good for practice purpose. Okay, so now here we can say I can say Python L1, or let's say L is equal to 1 2 3 comma 4. Okay, and I will just say L and we run it. Okay, it's going to connect. Okay, so this is the nothing but the homogeneous. Okay, so this is nothing but the homogeneous. This is type of list is called the homogeneous. Okay, so heterogeneous, we're going to create the list, second list. Okay, so there we can say 1 comma 2 comma a, okay, comma 3.3, and we can say against give some string like Pune. Okay, so this is the nothing but the, we can say it is a heterogeneous. Okay, so heterogeneous and homogeneous you come to know. So homogeneous means a similar type of data. So here we have integer type of data. Okay, and in list basically we'll say L1. Okay, L1 we have homogeneous data and L2 we have heterogeneous data. Okay, so we can print L1 and we can print here L2. Okay, so we are going to print both list and we get the data as it is. Okay, because we are given string here a, and for L2 we can say it is L2, or we can simply say L1 data hyphen data and L2 data. Okay, so it's easily come to know so which list we are running and what type of data is there. Okay, so 11 data is a homogeneous data because 1 2 3 4 are same type of variables are there, same type of data type is there for all data points. Okay, and then L2 is we have 1 2, that is a numerical, then a is a string, then 3.3 is a float, then again we're going to sing. So this is nothing but the difference between homogeneous and heterogeneous. Okay, so that is first point we have covered here about the Python, sorry, list. Okay, element wise operation is not possible into list because we have set of elements. Okay, so we can say we're going to access the things into index wise here. Okay, so we're going to access the index here. So element wise operation, why it's not possible element wise operation, because in list we don't know what are the data points are coming or what are the data is coming. So in first case we can say we can apply every operations on single on L1 list, but it is not possible to on L2 because the a and Pune, these are the different data type apart from this, because these are the numerical category and these are the string category. So that's why the element wise operation is not possible into the list. Okay, that is the point. So Python list is a by default n dimensional array, but we can create the multiple dimension array, but it is 2 will be the one dimension array storing another one dimension array. So it is going to list nested list of at the memory level. Okay, so I'll just create the we're going trying to create the nested list. Okay, n underscore list, I can say list. Okay, so here we're going to create 1 2 3 comma 4 5 6 comma 7 8 9. Okay, so we're going to create 3 by 3 array here. Okay, so we'll just go and print it, or we can simply n underscore this one. It will give the 3 by 3 matrix for us. Okay, so it is not actually matrix, it will create the at the end. If you see, even if we create the 3 dimension for this list, okay, at the end it comes under the one single list. This is we call the at the end one. It is a 1D array for us, because even this single dimension n list array having 3 different dimension inside the list, but ultimately it's going to point to the one single list, which is the indicating this square bracket. Okay, so because this square bracket indicating that, so this is the single this under this 3 dimension array, or this 3 dimension under comes under this single dimension. Okay, that's why it is a one dimension array. It is don't have a matrix kind of things, which is possible into the numpy. Okay, we're going to see it. Okay, memory element. Okay, element of list need not to be continuous in memory. Okay, sorry continuous store into memory. Sorry for what. So what is the meaning of that, or what is the meaning of continuous memory storage? Okay, or in last video also we have saw that is a numpy is stored in a continuous place in memory. Okay, so that is called the locality of reference. Okay, which is not part of the Python. Okay, so what is means by in no sorry list need to be need not to be continuous in memory. Okay, so what is means by continuous in memory place? Okay, so we'll going to understand what is it. Okay, so we are just going to draw one array here. Okay, so basically we can understand here. Okay, so for here we're going to say 1, here we're going to say 2. Okay, here we can say A, here we can say 3.3, and here we going to say Pune. Okay, so this is our array we have right now. So this is the 0 index. Okay, this is the 0 index we have right now. Okay, and we are going to pointing just wait for a moment. Okay, so now we have 1, we have 2, we have 3, and we can say 4. Okay, so we have 1 2 3 4 and 5. So 5 element we have. Okay, so element wise we have 5 element in the list. Okay, so this is the L1, this is the L1, just bear with my diagram. Okay, and indexing wise we have 4 element, because indexing start from indexing. Okay, so indexing wise 0 1 2 3 4. Okay, so in memory, okay, in memory how it's get represented. Okay, because if you see here, it is an integer type, it is int type, this is also int type, this is a string type, okay, this is the float type. Okay, and this is again int type. So if you see, so every object has a storing capacity. Okay, so we can say int is 4 byte, or string is 250 bytes. Okay, so if you draw the array here, why it is not in store in continuous place, memory location, in continuous memory. Okay, so because the thing is that in array, if you see at a memory level of Python, okay, so might be one get stored here, okay, because it's have a 4 byte memory locations. Okay, so all 4 byte or 4 byte object gets stored here. This a gets stored here, okay, because it is a string and it might be have a 256 byte. I am not sure it is 256 byte, and might be Pune gets stored here due to the byte of storage data, or we can say the variable size. Okay, so that's why there are some elements, if you see here, these are the empty. Okay, because the nature of data types, because we have here we say this is the heterogeneous data type, it is not a homogeneous data type. Okay, because in heterogeneous we have different type of data gets stored in a single list. Okay, so due to that the Python are not going to store the variable and in continuous place, means 1 2 a 3.3 and Pune. Okay, so and Pune. So this is the way we're going to store the continuous. This is the way where actually the object gets stored in continuous place. So this is the reason, that's why the object is not going to store into continuous place. Okay, so where is, because of this architecture, or this is the memory pattern where actually object gets stored in Python. That's why it's make a difference. Python is Numpy is more faster than Python. Okay, so this is the point we have clear here. Okay, then second thing, what are the other overhead we come with the Python? Okay, element overhead. In list, Python store additional information of each element, such as the type and reference count. This overhead can be significant when dealing with the large number of elements. Okay, so if you store object here also, this going to store the some data type of the object. Is what type of data type? So it's 1. Okay, so if its count is there, let's consider I have created here one more element, or one more box is here. I can give here 1. Okay, so I just, okay, so for Python they have to plus 1 count, I have to maintain in Python level. Okay, so that is one of the overhead they have. Okay, so there are some other attribute the Python have to store into their memory level, or what we can say that the compiler interpreter level. So that's why it is a element overhead. Okay, so data type list can handle the hold the different types of data type, which is decrease the memory efficiency and slow numerical operations. Okay, that's we already see, that is a homogeneous and heterogeneous. So due to this type of natures list have, so that's why it's taking more time to processing. Okay, that's the second point we have clear. Memory fragmentations. Okay, so list may not store element in the continuous memory location, which we already talked about here. Okay, so causing the memory fragmentation and inefficiency, because if you see here, okay, it is very easy to read and access this list, and it's very difficult to read and access this list, because there are some location, some block of address, or what we can say the uh, memory address are empty. So due to that they have more fragmentation. There are more chances that are we are getting error while reading the data, or while reading the list from the in Python. Okay, that is the difference actually. That is, so the performance are not optimized for numerical operations. That is true, because Python has a homogeneous and heterogeneous list has a homogeneous and heterogeneous data type they can hold. Due to that it's a slower operation. Okay, so basically Python is not meant for the numerical operation. Numpy is meant the functionality. The Python can list can store the data type, but lack serialization, Numpy function or numerical operation. So lack of serialization, because still we are going to pointing to this continuous in memory location. You cannot be create the serialization because of the in continuous in memory locations. So these are the list of other points we can say. So now we are going to the numpy. Okay, so numpy homogeneous data type. Okay, so numpy array store element of the same data type only. They going to they numpy are going to say np. Okay, so numpy only going to store only same type of data, not a heterogeneous in nature, only homogeneous in nature. So either can store integer, either can store float, either can store the uh, string. If you are able to create uh, heterogeneous data in numpy, it will throw an error. We will see it practically actually, but right now for understanding I am just creating it. Okay, so here if you see here I have give the string as a. Okay, and if you see here 3.3 as a float. So other variable data types are, other data points are integer in types. So this is not allowed into the numpy because they are only store the homogeneous, means similar type of data they are going to store, and python we are going to say store the homogeneous and heterogeneous data. That point is clear. That's why it is very more efficient to compact memory management. Okay, so fixed data type, that's we are talking. Okay, so fixed data type reducing memory overhead to eliminating the need to store data information of each element. Because if you see here we can say if I create the array of a, I know array of a of only type of integers, so I need not to be maintain the this element in like list, this element is integer, this element string. Okay, here I know what are the array I am going to create. I am create the integer type of array, so I need not to maintain the each and every element information. Okay, continuous in the memory locations I will going to show it. Okay, the array metadata, the numpy array have the extra metadata like shapes, stride data type. However, the overhead is usually similar, smaller than the pre-element overhead list. Okay, so I will be explaining to much better in the next upcoming video, where we're going to see the what type of shape is there, what type data type is there. Okay, there are some function available in the numpy regarding the array metadata. Performance wise, numpy array are optimized for the numerical computation with efficient element wise operation and mathematical function. So element wise operation we can going to see the detail in upcoming list, upcoming videos, where we can say, and we always compare with the python, why what is the element wise operation in python and what are the element wise operation into the numpy. We are going to see detail. Okay, these operations are implemented in c, resulting in faster performance than equivalent to operation in python. Okay, so now we see here. Okay, so the python are not storing memory object or data object in memory, not in continuous place. But if you see here, I know I have created one array. Okay, so I will just remove it. I will say it is a I will say it is a. Okay, and it is a type is int. I will just write here for information. My drawing is very bad actually. Okay, just sick for understanding. Okay, so here if you see here, first thing is that I know my all data types are my data are for similar data types. Okay, all data like 1 2 3 4 are integers, so I can store in one in continuous type 1 2 3 4 5. Okay, and so and continue, because here I need not to keep some places we are storing other object. Okay, here if you see here, these are the empty points, because one I can store, then I can going to give one to, then I'm going to store a string object, then I have to give some places for floating, then again I have to store some string object. So these list object are not stored in the continuous place but in NumPy, we are going to store the object in continuous place. We need not keep any empty space for other objects. Okay, so that's why it is very easy to read. It is very good to do the manipulation, do the sum of do the it is good in terms of optimization, all these things. That's why NumPy are very efficient and very fast compared to pandas. Okay, so I will going to share this my best drawing with you. Okay, I will just store first, and uh, I will share with you all this my docs on my GitHub link. Just go ahead and uh, see, and you can download it, you can read it. If you have some point, if you have any clarification, if you have some additional point, please let me know. We can improve these videos and video series one by one. Whenever if you have inputs, that is very what we can say, those things are best for me to understand and improve my teaching and learning skill also. Thank you so much for the watching video. Please do like, subscribe, please comment whatever comment you have, please comment it, because your inputs are going to make me better. So please comment what you have. Thank you so much, and please subscribe my channel, comment my channel.